In this video, we're going to be discussing user-defined functions and stored procedures. Let's start with user-defined functions. We've played with functions before. We've done stuff like average or sum, min, max, round, floor, ceiling. There's a whole bunch of functions we talked about. However, the people at SQL who wrote SQL knew that they couldn't account for every function. Sometimes you need to write your own functions because everyone's data is going to be different. So they give us the ability to create our own functions. And just to go back to basics here, a function in any language always returns a single value. It doesn't matter whether you're in C# or in PHP or C or C++ or the only language that changed this was Python. Python made an exception. But every other language, a function will always return a single value. So, whether it's a function or a stored procedure, and don't worry about stored procedures, we'll get to those in a moment, we can declare variables in them just like you would as if you were writing a function in C#. However, the types are going to be the same types we use in the database. So we can declare integers, varchars, either date stamps or time stamps, or date times, tiny ints. They're going to be the same types of variables that we've used in the database. So let's actually get in and take a look at a function here. First thing I want to explain is a delimiter statement. It's delimiter, a space, and then some symbol. And we're going to use two $signs. What a delimiter is the end of line statement. And up until now, delimiter has always been a semicolon. So if I click in here, you see it highlights the D from declare all the way up to the E in current date. That's because the D is the first character after this, which is the delimiter, and the E is the last character before the next delimiter, so it's everything between them. However, there's times when we run a function or a stored procedure, we're going to have several statements in between that need to be separated by semicolons. So let's go into the statement, then I'll go more into the delimiter. We're going to create a function. I'm going to call it getSum, and I'm going to pass it A, B, and C. All three are decimals, 12, 4. And what the 12, 4 stands for is the decimal is 12 digits in length, and 4 of them are to the right of the decimal place. So we're going to pass in these three variables, and what it's going to return is also a decimal, 12, 4. And then there's a begin and an end. Notice if I click here, the C gets highlighted to start with, and the end gets highlighted to end with. Now in between here we only have one statement. This could get larger, but what I say is return A plus B plus C and semicolon. Well, if I didn't have this delimiter here, and I'll comment it out, what'll happen is, look, we have the create, returns, begin, I say return A plus B plus C, and it ends here, because that is the end of line. That's the end of the command. This will never run because it'll always say you're missing the end statement. Well, if I have a statement in here that ends in a semicolon, you see the predicament I'm in. So what I need to do is to be able to have statements between the begin and the end that end with the semicolon, but when I run the create statement, I needed to run those not as part of the declare statement, but as part of the body of this function, and then include the end statement. So watch, if I go ahead and take the delimiter statement out, and by the way, there has to be a space here. If there's no space, this will not work. That, yeah, see how it highlights everything? There has to be a space. Now, it highlights all the way down to the D, so it's going to run all of this as a single statement. Then when the function runs, the body gets run, and because the semicolon is the default delimiter, the default end of statement, we can now put multiple statements like that inside of a function. Okay, so if I run this function, I actually just ran it. It says right here, there's getSum. You probably are not going to get this error. I've actually run this before. And what we'll see here, I'm going to reset my delimiter back to a semicolon. Again, make sure there's a space. And I'm going to select 1.11, 2.444, 3.6444 as sum. I do not have to put a table here because these are hard-coded values. If these were coming from a table, meaning they were columns, I would of course need a table. But if I run this now, 7.1998. It summed these three up, exactly what we wanted this function to do. Now, previously we talked about subqueries, and I said a scalar subquery is a lot like a function. So let's go ahead and actually see how they're interchangeable. Okay, so here is the scalar subquery we used previously. It's going to select the top 10 users, because I set a limit 10, and it's going to select the user ID, and then this value here is the result of this subquery. It's returning the email count. And if this was a function, user ID would be the argument, because I need to pass it the user ID to get the count from user email, where user ID equals whatever the user ID is from the users table. Okay, let's transform this and make it look a little cleaner and make it an actual function. So I'm going to go ahead and set my delimiter because I'm going to be creating a new new function. I'm going to say drop the function if it exists, and if I give that a run, you'll see that it drops it. If it doesn't exist, it'll still run it, but it just won't do an error. Now, I'm going to create a function called getUserEmailCount. I'm going to pass it UID. By the way, these names should not be the same names as the columns in your table you're working with. Like, I wouldn't call this user ID. I would maybe call it T for temp, T user ID. I'm calling this UID. And the reason is, if you put it in a statement and it's the same columns that are in the tables, it'll get confused. That'll make more sense in a moment. But here I'm going to pass in the user ID as an argument. So when I call this function, I pass it the user ID. I say it's going to return an integer. Now this part here where it says read SQL data, I don't believe it's required. It's more of just a courtesy to say in between the begin and the end, we're going to have actual select statements. Okay, so now between the begin and the end, this is called the body of a function. We're going to declare R as an integer. I'm going to select count star into R from the user email where user ID equals UID, meaning this value. So this UID becomes whatever value we pass in the argument. And here, the reason why this looks a little different is we're going to select count star into R. We just declared R here as a variable, so whatever this comes back as, a 1, a 2, a 3, a 0, whatever, it goes into the variable R, and that's a local variable to the function. Then it's going to return R. So if I run this, check on the side, it did get created, there was no errors. I'm going to reset my delimiter, and now instead of, I want to move this down so you can see it all on one screen here. Instead of running all of this, we've actually replaced this with this function called getUserEmailCount. So this, line 23 to 27, now becomes these two lines. So I'm going to select the user ID and the getUserEmailCount, and I'm going to pass it user ID as email count from users limit 10. This yields the same results as if I ran this. They are completely interchangeable. So why would I use one over the other? Well, one thing to note is when you create a function, it's here for everyone to run. And I really think it's messy when you go look at a database and they have like 100 functions. It means they've just created them on the fly. They really haven't done much planning. It's very messy. A lot of times when you have different developers developing functions on their own, and they're functions available to the entire database, you may have multiple functions that do the exact same thing. So it's messy. But the rule of thumb is if I was to write this and it was only going to run maybe one page, go ahead and just make it an inline subquery, scalar subquery. However, if it's something that gets run a lot, maybe the email count is extremely important to your system, then you can go ahead and create a function on it. Okay, let's look at a few examples now of what's called a procedure. Let's see here. A procedure is a little different than a function in the sense that A procedure, you can declare multiple in, out, and in-out variables. And the in or the out is the direction. Meaning, in a function, these are always in, meaning when I call the function, I pass these into the function. In a procedure, we can declare some as out, meaning when I call this, I'll put a variable instead of an empty variable, preferably, and it'll get populated after the function runs, after the procedure runs, excuse me. All right, real simple. Let's go through this example. I'm going to set my delimiter. I'm going to say create procedure, proc test 1. Incoming will be var1 as an integer, and out will be var2 as an integer, and there will be a third variable, var3 as an integer. Okay, there's a begin and there's an end. And then in here we have multiple statements. Again, this is where that delimiter comes into play, that we have multiple statements between the begin and the end that end in a semicolon. We want the whole thing to run as once, so we have to use a delimiter. So here, I'm going to say let's set var2, which is this variable, the out variable, equal to var1 plus 2. So whatever I pass in, it's going to add 2 to it and pass it back out. And then var3 equals var1 times var2. So this, whatever I pass in, we're going to multiply it by 2. Whatever I pass into var1, I'm going to multiply it by 2 and then pass it back out. So I'm going to run this, and what we'll see is it shows over here there is a color differentiation. That way you know which of the functions and which of the procedures. And let's call it. And how you call a procedure is actually quite differently. I'm going to reset my delimiter, and instead of doing it inside of a select statement, well, remember, if it's inside a select statement, it acts like a scalar subquery, and the rule is a scalar subquery has to return a single value. Here we can have multiple values, so we have to call it a little differently. So here I'll say call proc test 1. I'm going to pass it a 4. And then these two, result 1 and result 2, begin with an @ sign. In SQL, the @ sign is the sign for a variable. And it's a variable that takes place only for this session. What I mean is, when I run this, these are going to get declared. But if I go ahead and I shut down SQL Pro, they're gone. They disappear. They're stored locally here, not in the database. So if I run this, it ran, we get nothing back. However, these two variables were now declared, result 1 and result 2. So if I want to see what's in them, I can say select result 1 and result 2. And there's a 6 and an 8. Well, I passed it a 4. 4 is var1. var2 is 4 plus 2, which is 6, so there's our 6. And we passed in the 4. 4 times 2 is 8, which goes to var3, which went into result 2. Again, these are the 3 arguments I'm passing. These are the 3 arguments it receives. So 4 times 2 is 8. There's an 8 as result 2. So stored procedures and functions are a little different. Functions usually, well, they always return a single value. They're used for more calculations. You've seen something like average. That's a great function. Stored procedures tend to be a little bit more robust and complex. They tend to do things based on some type of activity. So here's another one I put together. I'm going to create a function here called getFullName, in which I pass in a user ID. And what comes out is the full name. So here, after the begin, I'm going to select, concatenate the first name, space, and a last name into full name. From users, where user ID equals UID. So I'll run that. And then if I run this, and this is a user ID I previously created, and there's full name. Well, it runs, but again, I don't see anything until I say select full name, and now I get that full name for that user. I want to go ahead and expand this just a little bit more. Let's say instead of just returning full name, I also wanted to return, let's make it, I don't know, 100, and I want to return also their first name. In fact, we could put this on 2 lines. And I also want to return their last name. So now I have one variable going in as user ID, and out I come the full name, the first name, and the last name. Okay, the reason why I'm showing you this is if you select multiple columns inside of a function, it has to be done a certain way. The into statement can only occur once. So I'm going to put this to the second line and say what I want to select is the concatenation. Then I want to select the first name and the last name. So I'm selecting three here, three different columns. The way this will work is you can only have the into statement once. So I'll say select them into first name, full name, first name, and last name. It has to be done like this, where you select as many columns as you want and then into all of the variables. And again, these variables, there is no declare statement like we did in the function. The reason is they're declared over here. We've already declared them as the parameters, the arguments. So I'm going to go ahead and drop that getName function, and I'm going to recreate this. And now I need to change this. I need to add on @ first name, @ last name. And then when I do this select over here, let's select all of them. So I'm going to run this now. Again, runs without errors. And now when I do that select, oh, we get nulls here. So what happened? Let's make sure everything looks fine. Select the concatenation, the first name and the last name into full name, first name, last name. I'm going to go ahead and remove. Shouldn't make any difference. Just want to make sure all of this works. First name matches first name, last name matches last name. Okay. Oh, this is what happened. Because first name and last name are also column names, it's confusing them. So here's what I'm going to do. Instead of calling it first name, I'm going to call this F name, and I'm going to call this one L name. And then when I do the select, I'm not going to use first name because now the variable is F name and L name. So let's drop that again, and let's recreate this. Run it one more time, and now we get all the names back. So remember, do not use column names as variable names. They should be different. If you do use column names, it will confuse them, and we got all nulls back. That was bad. Okay, so the next thing I want to show you about a stored procedure is it's a big example, and this is how stored procedures are usually done, something large like this. And let's take a look over here. I reset my delimiter. I'm going to drop it if it exists. And then I'm going to create a procedure. I'm going to call it create user. And if you remember, users are rather complex entities, meaning they're not in one table. They're in the users table. There's user emails, there's user phone, there's user addresses. They're spread out among multiple tables. So if we were putting a procedure together to create a user, I could do this where I'm taking in the first name, the last name, the middle name, username, password, gender, income's birth, cell phone, primary email, address, city, state, zip, and out, my out variable is going to be UID. Now, this is the one case where I am using names from the tables, but it works a little differently if we use them as an insert because the insert knows their values. Again, usually not a great practice, but let me show you why this is working here. So in between the begin and the end, I'm going to declare new user ID as a varchar. Remember, that new user ID is what we're going to go ahead, that's going to be the person's user ID. We're creating a new user. Then I'm going to set new user ID equal to a function called UUID. UUID is a function pretty much available in every language, not just SQL, but it's going to generate a value that looks like this. And that value is guaranteed to be unique. It's based on your MAC address, the date and time, your time zone, and a bunch of other information. It's a big, huge alphanumeric string. It's guaranteed to be unique. Okay. Next thing, I'm going to set UID, which is my out variable, to that new user ID. So we're going to pass it back out. For the moment, ignore this start transaction. First, I'm going to insert into the users table user ID, first name, last name, username, password, gender, date of birth, and the values. Okay. Next, I'm going to insert into the user email table, same values, user phone, user address. For now, ignore the commit for a moment, and then end. So if I call this, it's going to insert into 4 different tables. Between the begin and the end in a procedure or a function, you can have as many full SQL statements, meaning selects, inserts, updates, deletes, as you choose. I've seen functions and stored procedures in excess of 800 lines of code. They can get as huge as you want. All right, so right now, let me run that. And it ran. And I'm going to reset my delimiter. And I'm going to create a user here, and I'm passing in all that information that's required, all of those fields that I defined up in here. So if I hit run, it says we have an error to the right of question mark. Let's take a look through here and see. If you've been copying and pasting from the Word docs or the PowerPoint docs, you may notice, and I should have mentioned this earlier, some of the semicolons look like this, while some of them look like that. This is a single quote. This is an apostrophe. So you need to correct that if it's to run. And as I look through here, it appears there might be another. And the reason I say that is that it's highlighted all the way down. It appears I'm missing one here. There we go. So now I run that and it runs successfully. I'm going to select that at UID, which is the out variable for this procedure. So this is the ID created from this statement. That's the user ID for our new user. I can go ahead now and say select star from users where user ID equals that value. And here is Bain Smith and all his information that I passed in. And what I can do is take that statement. By the way, if you edit a field and it thinks it's a text field, because we didn't define this, it's not from a table, it may open up like that so you can put in a lot more data. It's the same as editing it. It just thinks it could get bigger. So if I take that and I go over to something like, well, we inserted into user email. So let's go to user email. Let's go to content and say where user ID equals that value. And there it is. And we could do the same thing for user phone and say where user ID is that value. And there it is. So it went through and actually created all of those entries in these tables. Okay, when I first went through this, I said please ignore the start transaction and the commit. Now let's revisit them. What the start transaction means is everything between the start transaction and the commit, meaning these 4 statements, they will either all fail or they will all succeed. The reason why we do this is we wouldn't want a halfway created user. Maybe when they sign up, we take this information and the first thing we need to do is call the user. Would you really want to insert into the users table, user email, and then go to insert into the phone and, I don't know, maybe we have a unique index on that phone, so for whatever reason it errors out. And now we don't have a phone number. However, that username he chose and all this information is still in the users table, so we have a halfway created user. This is bad. By putting it in between the start transaction and the commit, what will happen is it'll insert into the users table, it'll insert into user email, and then when it hits phone and it has an error, it will go back and undo the insert into the user email table and undo the insert into the users table and then reply with the error. So everything between the start transaction and the commit, all of those statements, and they don't have to be inserts, they could be updates and they can be deletes as well. But everything between those two statements either succeeds or it all fails. And that's really it. Okay. And that is stored procedures and functions. By the way, stored procedures, they're still used heavily by Microsoft products. The problem is the data, the actual procedure is stored in the database. So it really marries you to a database and you can't change away from it. You'll know that sites, websites or mobile apps may start in one language and then change to another. Like, what is it? Not Twitter. One of them used to be written in Cold Fusion, and they switched it over to PHP, and they moved on to a different language. And they picked the best language that fits their needs, and over time that may change. With these stored procedures, because they're stored in a database, once you start with a database, like let's say you start with MySQL, if you grow and now need to move on to a larger database, something that handles more volume like Oracle, you can't. Unless you go ahead and, at a cost, rewrite all of these, because the language for a stored procedure in SQL, MySQL, is completely different from Oracle and completely different from SQL Server. They did not get on the same page with this. They are all completely different. So Microsoft still in their .NET framework relies heavily on stored procedures, but a lot of other languages have gotten away from it and moved their functions and this type of activity more towards putting it in whatever language you're working with instead of the database.